Good afternoon, and thank you for joining us for our June Rebel Recharge Lecture. We are very pleased that so many of you have joined us and chosen to be with us as we've shifted our traditional face-to-face programming format to a virtual format in an effort to continue to inform and engage our alumni community in these current times. My name is Stacy Purcell, and I am your president of the UNLV Alumni Association. It's my honor to personally welcome each of you here today. I would also like to give special recognition and welcome Blake Douglas, our interim associate vice president for alumni engagement, and he's also our executive director of the UNLV Alumni Association. Welcome, Blake. And in addition, I would like to thank Renee Rivera Gelfi, coordinator for programs and events, for producing today's virtual lecture and all of the series. For more information, please visit our website, engage.unlv/events, for upcoming topics and events, as our goal is to continue to grow this program and create opportunities to engage with our alumni, faculty, staff, students, and community members. And now it's my pleasure to introduce our speaker for today's program, Dr. Kristen Averyt, research professor in the Office of the Executive Vice President and Provost and the State of Nevada Climate Policy Coordinator. We're excited that Dr. Averyt, just one second. I'm so sorry. Dr. Averyt is a research professor at UNLV focusing on climate resilience and urban sustainability. She has a long working record on different facets of public policy and decision making. In the recent years, she's focused on the energy-water nexus, climate and Western water issues, including the Colorado River, and most recently, urban resilience and sustainability. In 2018, she was named one of Northern Nevada Business Weekly's top 10 innovators of the year and a top 10 woman of exemplary achievement. Wow. We are excited that Dr. Averyt is here with us today to share her passion and perspectives for climate change, what it means for our planet, our state, and our community. Please join me in welcoming her. Take it away.
Well, thank you guys. Thank you all so much for the invitation. It's really an honor to present to this group, and it's just been fabulous. I've been at UNLV for just about a year so far, and I've just had such a tremendous experience getting to know the folks across the university and so many of the alums. And so I just want to thank you for all you do in the community and connecting the folks in our community with the university faculty. So today I am going to talk about climate change. You know, it's a difficult conversation, or it's a difficult topic sometimes to talk about, but I think it's really important that we understand how climate change happens, how it's specifically impacting our community, and then finally, what are we actually going to do about it? So I like to start my talks with this image. And this is actually, I like this image for two reasons. It's actually a picture of the Front Range of Colorado, and you can see the snow on the Rocky Mountains. And the two reasons I like this photo, first of all, I just think it's really cool. It was actually taken when somebody connected a GoPro to a weather balloon that was launched by the Weather Service in NOAA in Colorado. And the second reason that I like it is it shows how thin that blue line is. That's actually our atmosphere. And if we didn't have the atmosphere, our planet would be 500 degrees when we face the sun, and we would be minus 500 degrees if we were facing away from the sun. The reason that our planet is habitable is because of the atmosphere, and very specifically because of the greenhouse gases in our atmosphere. The greenhouse gases attenuate the radiation that's coming in from the sun. So what happens is the sun, it hits the earth, and it actually warms the landscape. So it warms the land and it warms the water. Well, that heat is actually irradiated back into the atmosphere, and it's absorbed by greenhouse gases. And that is why we have this nice blanket around our planet that protects us from the sun. But right now we're adding so much carbon to our atmosphere that instead of just having a thin blanket, we have about 4 duvets worth of blanket over our planet. And that's how warming is happening. I also like to show this video, because what this does is this actually gives us a picture of how carbon dioxide specifically has changed across our planet through time. Now, what you see on the left, the baseline, the start of these measurements is January of 1979. And that left-hand graphic that's moving, you see the increases in measurements from the 90 degrees south is the South Pole, 90 degrees north, North Pole, and you see the increases that are happening through time. Now on the right side, you actually see the trait, you see these what I like to think of as the breathing of the planet through time. So what happens is during the spring and summer when things are blooming, they're breathing, our plants are breathing in carbon dioxide. And then during the winter and the fall months, when things decay, you're breathing out carbon dioxide. So that's why we see these small scale changes. But you see that long-term trend on the right of increases, that is being driven by the emissions of carbon into our atmosphere starting roughly about the time of the Industrial Revolution. Now I'm going to let this run for a little bit longer, and you can see that there are more measurements through time as we move forward. And I think it's important to realize, as of May, the atmospheric concentrations of carbon dioxide are 417 ppm. That's the highest that the concentrations have ever been since people have inhabited the planet. And about a year ago, it was at 415. So concentrations have increased by almost 2 ppm in a year. Now what's happening on the video is you're getting a picture of the observations that happened just in the Northern Hemisphere that began around the 1950s. Now we're going to go even further back in time. We're actually able to show or to reconstruct atmospheric carbon dioxide concentrations over the last 800,000 years through ice cores. When ice forms, you'll notice that sometimes there's little bubbles in it. Those are actually little encapsulations of the atmosphere at the time the ice freezes. So by pulling up ice cores from Greenland or from the Antarctic, we're able to sample the air bubbles in the ice cores and reconstruct carbon dioxide concentrations. And what you see here is that the concentrations through time, our concentrations today are higher than at any other point in time, almost double the highest concentrations that occurred over the last 800,000 years. The other thing that I want to bring up, because this is something that you might have heard about in the news and there's been a bit of discussion about, has been the impact of the pandemic and the shutdown on carbon dioxide concentrations. Indeed, our emissions are down daily emissions by about 17%, which seems like so much. Estimates are that by the end of the year, we could be down by about between 4 and 7% in terms of total emissions for this year. However, there's so much carbon dioxide built up in the atmosphere that the natural processes that would take the carbon out can't catch up. So that concentrations of CO2 by the end of the year are only going to be about less than half a part per million lower than they otherwise would be. And when you look at the annual increase of 2 ppm, this is essentially a blip on the radar. So what has this meant for temperatures? Globally, across the planet, temperatures have increased upwards of 1 degree. Now, I think I show two different measurements of temperature increase here because I think this is an important point. If you actually extrapolate between the year 1901 and 2016, linearly, you've seen an increase of 1.8 degrees Fahrenheit across the planet. But another way that scientists will oftentimes measure increases is they take the average from one point in time and the average for another. And we can use that kind of way to estimate increases. The temperatures have increased by about 1.2 degrees Fahrenheit. And scientists will choose different ways to measure this depending on how they're going to apply it in their science. But the bottom line is temperatures are increasing. But this is one reason why sometimes you might see different numbers quoted in the media in terms of temperature increases. Now, of course, what does this actually mean for us? Using the same type of measurement, globally, temperatures at 1.2 degrees, the southwestern US has warmed by 1.6 degrees. And this map on the right, this shows that there are very different patterns of warming across the Southwest. And specifically for our state, we have warmed faster than other parts of the Southwest. We've warmed by approximately 2 degrees Fahrenheit over the same period of time that the globe has warmed by 1.2. Now, what does this mean for the future? Now, what this graphic represents on the left-hand side, that black line, those are our global carbon emissions up to just past, really about 2016. And the red, blue, and green lines, those represent potential future emissions. Right now, our emissions trajectory of carbon is on track on that red track. It's on the quote-unquote higher emissions trajectory. But that blue emissions trajectory is really what we're aiming for. And the green, we're just not going to talk about that today. And quite honestly, it's not feasible. And then on the right-hand side, what you see are the correlations between the emissions and the temperature. That black line represents the global temperature trends. And then you can see on the right, those are the potential ranges for increasing temperatures associated with those emissions pathways. Bottom line is, it's going to get hotter. For the state of Nevada, these are our projections for increasing temperatures. By roughly mid-century, under that lower emissions trajectory, which we are really striving for, we could potentially warm by about 5 degrees Fahrenheit, recognizing that we've already warmed by 2, that's an additional 3.5 degrees. On the higher emissions trajectory by mid-century, we're looking of up to and kind of roughly 6 degrees Fahrenheit. Again, so that's an additional 4 degrees. But on that higher emissions trajectory, which is where we're headed right now in terms of our carbon emissions, we could warm by up to 10 degrees Fahrenheit across our state. And these numbers are I pulled them out there for Southern Nevada very specifically. And you can see actually in the northeastern part of Nevada, we're looking at upwards of possibly 12 degrees Fahrenheit of warming. So what does all this temperature increase mean for the state of Nevada and for Southern Nevada very particularly? Well, of course, you can't talk about climate change without talking about water. A lot of the impacts of climate change are going to be delivered and are being delivered through changes in the hydrological cycle. And the reason for this is that as temperatures increase, the atmosphere can actually hold more water. And so it's upwards of 4% more water for every degree that the atmosphere warms. So what that means is you have more evaporation occurring, right? So you get more clouds, more stuff happening up in the atmosphere, and it also dries out the landscape. Now, in Southern Nevada, 95% of all of our water comes from Lake Mead, and Lake Mead is fed by the Colorado River. This graphic on the left, or this map, actually shows the upper Colorado River basin and the lower basin where part of Nevada is situated. But almost all the water from the Colorado River actually comes from the snowpack that is really in the Rocky Mountains in northern Colorado and Wyoming. So what happens to the snowpack there is what defines our water supply. And I think this is a very important message here, and I'll walk through this. This upper left graph, this shows the declines in flows on the Colorado River through time. So this is roughly, the turn of the century through today. And then on the bottom, you see the increases in temperature. But you'll notice there the precipitation graph on the bottom right, there's been no detectable change in precipitation. So regardless of the fact that precipitation hasn't changed, the amount of snow falling hasn't changed over time, the increase of temperature is enough to evaporate enough water and make the landscape so dry that the landscape and all the plants are sucking the water out of the river. So that's enough to drive the decreases in flows in the river. And then this upper right panel, this shows Lakes Mead and Powell, which are the major reservoirs along the river. You see the filling of Lake Mead in roughly 35, and then the start of filling Lake Powell. Then you see the onset of the drought in the 2000s. And right now we're roughly at a place where with both Lake Mead and Lake Powell, we're essentially at a capacity where as if it was only one of our reservoirs being full. As for the future, this is our running water supply and then the water demands and water use through time for the water supply on the river. And these are the projections for the future. So this is something we really need to think about. Nevada is actually the driest state in that we actually get less precipitation than any other state in the US. Now this graph, and I'm going to take this opportunity to talk about water in a very different way that you may not have heard about. And I'm going to use this graph to start. Now this map, what this is showing is this is places where in general, over time, the local water supply, so the water that is right there where you sit and where you live is insufficient to meet the local demands. If you're a farmer, if you're in a municipality or the like. So these places in shades of yellow and red and orange, it doesn't necessarily mean that these places are running out of water. Rather that these places are either over pumping their groundwater supply, they are conveying water, bringing water in from other places, or they're recycling water. And all three of those processes require incredible amounts of energy. Somewhere around 15% of all the energy and electricity use in southwestern US is for water. So depending on where you live, there's going to be a lot of energy embedded in your water supply. So if you live in Manhattan, there's about a third of a kilowatt hour for every 100 gallons that you might use in your house. Northern California, you pump a lot of groundwater, and there you're looking at about half a kilowatt for every 100 gallons. If you live in Southern California, you have among the most energy intensive water. You're using up to 5 times more energy per unit of water to supply, energy per unit of water than in other places. So when we think about our water supply, we need to think about the energy use. Now, this is a map that shows all the major water systems across the southwestern US. And I shouldn't say all, most of the major water systems. And those are represented in blue. Now, those in red are under consideration or under construction. And to give you an idea of how much water we move around the Southwest, just those projects listed in blue here, they actually move as much water around the Southwest as the annual flows on the Colorado River. That's upwards of 12 million acre feet of water is being just moved across the Southwest to make sure that we have enough. And I always like to tell the story of the Central Arizona Project, which is the most energy intensive project in the entire US. And this illustrates the nexus between energy, water, and carbon. So the Central Arizona Project carries water from the Colorado through to Arizona, from the Colorado River, from Lake Havasu. So it starts at Havasu, it travels up to Phoenix, then up to Tucson. This is over 300 miles and it travels up 3,000 feet of elevation. And annually, this project alone uses 3 million megawatt hours of power every year. And up until recently, this water supply was primarily driven by the Navajo Generating Station, which is one of the most polluting coal-fired power plants in the entire United States. So if you were using a lot of water in Arizona, your carbon footprint was also pretty high at that point in time. Now they're looking to alternative sources to power the Central Arizona Project, but it's just important that when we're thinking about water, we're thinking about how we're going to adapt moving forward and make sure we have enough water, that we really think about where the energy is coming from. So now turning back to the other issues, you have to talk about water, but some of the other issues and other impacts. Now, with respect to increasing temperatures, we're already observing and we can expect increasing severity, intensity of our drought events. We can expect significant increases in the acreage that is burned through wildfires. We're looking at seasons that essentially there are no wildfire seasons. They're just going to be continuous exposure to wildfire. Precipitation is very interesting for Southern Nevada because we actually aren't confident about how these trends might change. We expect that there could be increasing variability, meaning that we might have more intense storms less often. And we're a little uncertain about the flood risk as well, because when we talk about urban flood, it's not just about what falls out of the sky, it's about what infrastructure we have in place to handle it. But I want to talk more specifically about temperature. It's not average temperatures that matter, it's actually very specific temperature thresholds. And I'm going to start with this one. Now, across the state of Nevada, the number of nights that exceed 70, there have been an increasing number of nights that exceed 70 degrees Fahrenheit. Now, 70 degrees is an important threshold. The reason being that it's roughly between 65 and 70 degrees where optimal sleep happens. So if you're somebody like, I remember when I was in school and I was trying to pay my way through college and through graduate school, I would turn off the air conditioning at night and open the windows. So you're going to be in a situation where people are opening their windows, particularly low-income communities and students who are like me, and they're just not going to get as good a night's sleep. And you might not think that matters, but it matters tremendously, particularly in terms of performance in schools. So that matters for our children. Now for Clark County, and these are very specific projections, some science that was done for Clark County, we can expect nighttime temperatures to continue to increase by another 2 degrees Fahrenheit before 2040. And we can expect 70 less days when nighttime temperatures don't fall below 50 degrees. Now, why do we care about 50 degrees? 50 degrees is when your lawn goes dormant. So this is when you don't need to water your lawn. So if the temperatures at night are not dropping below 50 degrees, this means if you have greenscape, you'll be needing to water your lawn year round. So this has very significant impacts in terms of water demand in the valley as well. Then of course, come on, we live in Las Vegas. We're all about extreme heat. but it's important. I think this is some very interesting work that came out of a group called Climate Central, and the state climatologist and I have looked at these data, and they're pretty good. Suffice it to say, both Las Vegas and Reno rank among the hottest cities and fastest warming in the entire United States. Las Vegas specifically, in the same time that I said Nevada has warmed by 2 degrees, Las Vegas has warmed by 8 degrees. And that additional warming is a result of the urban heat island effect. Now, urban heat island, the reason that this happens is essentially it has to do with the type of materials that we use to build our cities. A lot of times they're impervious, and that really means that essentially the landscape can't breathe. And so you don't have that evaporation and movement of moisture and wind through the cities that you need. And then second, it's because we tend to use really dark materials that absorb a lot of the light, or a lot of the heat, I should say. So temperatures don't cool very much at night. This is a really great, if you haven't seen this sculpture at Springs Preserve, I recommend having a look at this. This really illustrates how this works. So what this sculpture shows, there's temperature, or there's thermometers on both of these lizards. And I think the professor who actually took this photo, I think he said it was about 80 degrees this day. That white sculpture, it was registering a temperature of 96, and the black one, 142 degrees on an 80-degree day. So this is a great illustration of how the urban heat island effect works, and how we build our cities matters. So let's talk a little bit more about extreme heat. And these are pretty sobering numbers, I think. These are, again, projected data very specific to Clark County. By mid-century, we're looking at an additional 40 to 50 days per year that exceed 100 degrees Fahrenheit. And by the end of the century, over half our days every year exceeding 100 degrees. And the one that kind of bugs me right now, we only see about on average, 5 days per year where temperatures exceed 115. By the end of the century, we're on a trajectory where we could have 50 days per year in the Las Vegas area where temperatures exceed 115, 50 days a year. So what does this mean? Let's talk about this in another way. So extreme temperatures, the impact on transportation. This is really interesting and something that not a lot of folks think about. Believe it or not, airports in the US, specifically Sky Harbor in Arizona, and some airports overseas have had to shut down because at temperatures at about 117 degrees Fahrenheit, planes can't fly. And the reason is the way that a plane works is it's lift. And so you have the wing, and you have a whole bunch of molecules that need to hit the bottom of the wing to be able to create the lift for a plane to take off. Well, guess what? Hot air is not dense, so there's not as many molecules there to hit the wing of the plane. So planes cannot take off under certain circumstances. So imagine that we're in a future where with temperatures that hot, where we can only fly late night or super early morning. That would fundamentally change the way that we operate here in the Southwest. And then similarly, with temperatures that high, we're also looking at increasing demands on the grid for cooling. And we've seen what happened with PG&E and cutting off power. And so we really need to make sure that the grid is able to handle the demand, and that our energy systems are ready for this kind of temperature increase. And now I want to focus on public health, because this is something that's near and dear to me. And I think it's something that we really need to be paying attention to very specifically here in the Las Vegas area. The World Health Organization estimates an increase of over 250,000 deaths every year just due to the impacts of climate change. Now let's talk about some of the specifics here. Now, across the United States, heat causes the most weather-related fatalities than any other weather event. And these numbers, I'll say, for example, this shows that the 30-year average is about 136 people every year. We hosted a workshop at UNLV on public health and climate change prior to the pandemic onset. And I remember the head of the health district from Maricopa County was there. And she shared that in discussions with their coroner, they think that these numbers are underestimated by orders of magnitude. The second thing that's important, there are more heat-related mortalities in Nevada than in any other state. Last year, 72, that represents almost half of the total mortality that happened in heat-related across the entire United States were here in Nevada. And then finally, in the last decade, the number of people that have perished because of heat has increased. And that's some research that came out of DRI fairly recently. I think it was a year or two ago. And then pollen and allergies. I am a member of the Wheeze and Sneeze Club, and right now my allergies are getting absolutely hammered. And in Southern Nevada, the Pollen Monitoring Network, which is out of UNLV and it's a partnership with Clark County, they have recognized that the allergy season here in our area is starting earlier. What's also interesting is that it's the biology of a lot of our plants is such that you increase CO2, you're actually going to increase pollen production. And then finally, this map, what this shows is the increase in frost-free days that we've seen. And in our area, about 20 more days a year where there's less frost, not that we talk about frost very often in Southern Nevada, but what's still important here is when you have less frost, you're gonna have more weed production and you're just gonna have a longer allergy season. Then air quality and ground level ozone. Now, we know that long-term exposure to ground level ozone or smog really has significant impacts on human health, particularly pulmonary and cardiac issues. And ozone is a concern in Las Vegas. This map on the bottom, what this shows, that dark blue kind of dotted line on the bottom, that represents the air quality standard for the US. And then the light blue line on the top, that represents where we are in Las Vegas. So our air quality, our ground level ozone air quality is poor. According to the American Lung Association, we rank 9th in terms of the worst air pollution or air pollution in the entire United States. I will say that if you look at this trend, we are doing much better than we were before, but we still have a ways to go in our area. And then mental health. This is an important, very important, and this is something that's right now with everything that we're experiencing is coming up and really front and center in terms of thinking. Those who are exposed to these extreme weather events, say drought and major catastrophes, there is a lot of data that shows the implications for mental health. But something that I've learned very recently that I am just fascinated by, there's a team at Arizona State that's working on they think they might have discovered, and I'm going to say think, a link between schizophrenia and extreme heat. It turns out the same part of your brain that responds to that, where I'm going to say schizophrenia sits, I'm clearly not an expert on this, is the same part of your brain that registers extreme heat and extreme cold. And so there's a connection there. And their thought and some of their initial findings indicate that increasing temperatures can increase schizophrenic episodes. So this is something that, again, these things that you might not otherwise think of are really, we're learning so much. And then vector-borne disease. And I apologize that this isn't a great map here, but what this shows, it's not great quality, but what this shows in yellow, and I think everybody can see at least that this is a map of the globe or of the world. In yellow, this is where the mosquitoes one of the major mosquitoes that carries malaria, this is where they live. And in red, these are places where roughly by 2050, this mosquito is going to be able to live because of the changes in our ecosystems. And you'll see that little tiny red dot over in North America in our neck of the woods, that's Southern Nevada. So this is really, I think this is a place where we need more research to really understand our risk to exposure to vector-borne disease and to see what new diseases might emerge in our area. And then finally, I want to talk about climate justice very specifically. I pulled this quotation from the US National Climate Assessment, the last iteration, which was in 2018. People who are already vulnerable, including lower income and other marginalized communities, have lower capacity to prepare for and cope with extreme weather and climate related events and are expected to experience greater impacts. And this is a headline I pulled out of E&E News just from a week ago. And this is based on a recent study that shows flooding disproportionately harms Black neighborhoods. And this is the flooding that's associated with catastrophic hurricanes and major storm events in the southeastern US. So this, again, our low income communities, people of color are being disproportionately impacted by climate change. And this is some excellent work that was done. Actually, it was an analysis by NPR. And this is what really brings this home. I find this incredibly compelling about why we need to act on climate change here in Las Vegas. There was this analysis. What the team did is they actually looked at I think it was over 70 different metropolitan areas across the entire United States. And what they did was they broke down the hottest places, how the temperature, the extreme temperatures in these cities, and income level. And there were 9 different cities across the United States where there was a very strong correlation between the hottest parts of the city and where the poorest people live. And 2 of those 9, one is Las Vegas and the other is North Las Vegas. So now let me bring air quality and COVID-19 into this entire discussion. Preliminary research, and I want to emphasize preliminary because, you know, right now, and I'm just going to step aside and get on my soapbox here. Science is iterative. One study doesn't say this is the way it is. It takes time. And right now with the pandemic being front and center, we're seeing science happening in real time. And so there might be a headline over here about, oh, COVID does this, a headline over here that says COVID did this. Science takes time to really settle on consensus. So I really want to emphasize this preliminary component and how science works, because I think right now we're kind of getting whiplash with all these headlines around what we should and shouldn't do. An increase of 1 microgram per meter cubed. Microgram is super tiny, meter cubed, big hunk of air, of fine particles increases the COVID-19 death rate by 8%. So what this is saying is that if you increase particulate matter in the air and you're exposed to that for a long period of times, you're more likely to die from COVID-19. This was some work that came out of Harvard. It was well publicized recently. We'll see where the numbers settle out. But what I will say is that this isn't surprising. There's a huge body of research that shows that air pollution related diseases are most prevalent among minorities and the marginalized. And air quality, as I showed before, it impacts your heart and it impacts your lungs. So it's no surprise that there's some sort of connection given what we know about predisposition to COVID-19 and mortality. And then finally, we've heard and we know, at least all the data point to, that Black Americans are disproportionately impacted by COVID-19. These are the latest statistics as of June 10th for the entire United States in terms of the numbers of folks from different racial backgrounds and mortality. 62 Black Americans die for every 26 that white Americans that have died from COVID. And this is nationwide. Let me show you the data for Nevada. So this is the chart, and what we see here is that Indigenous peoples in our state have disproportionately perished as a consequence of COVID, followed by the Black community, by members of our Black community, Latinos, white, and then you can see kind of the total statistics. So again, what's happening nationally, it's not a perfect analog to Nevada, but again, we do see disproportionate impacts to our communities of color. And this is something that I think we need to really be planning for. In fact, I just heard this discussion on KNPR this morning on State of Nevada. This headline says it all. A summer unlike any other. As underserved populations face hotter neighborhoods and limited access to air conditioning, the pandemic threatens the malls and libraries where they typically find relief. Cooling centers are designed to be large places where people can congregate, and we need to be very careful about how they're designed and what we do to make sure that we're protecting our communities. I think one thing that we need to understand when I talked about heat-related mortality, unfortunately, the majority of folks that perish as a consequence of heat, they actually succumb in their own homes where they don't have the air conditioning on because they either don't have air conditioning or because they don't have the money to pay their energy bills. So that was pretty sobering and, you know, really light and easy topic, I know. So now let's turn to what we're going to do about it and what we need to do about it. I will just say, first of all, there is a lot of planning and a lot of different multiple efforts across our state and in our communities down here to coordinate and figure out how we're going to address the very specific issues that I just outlined. But I'm not going to talk about what I would characterize as climate resilience and adaptation today. I want to focus very specifically on the mitigation component, that is reducing our carbon footprint. Now, several years ago, at the United Nations Framework Convention on Climate Change, the Paris Agreement was agreed to. And I think folks have probably heard about this in the news, but really the meat of the agreement was that internationally, folks were going to try to limit global temperature increases to 3.6 degrees Fahrenheit. Recognizing that 3.6, that already includes the warming that's already happened. So we're between 30 to 50% of the way there towards this 3.6 degrees. So how are we doing in the US with our carbon footprint? This shows the carbon inventory from 1990 through 2018. Now, our emissions actually between 2017 and 2018 went up by about 3%. And there's a couple reasons for this that I'll get into. But what's important here is that we're only at 10.2, we're at 10% below the 2005 levels. And per the Paris Agreement, we need to be at 28% below by 2025. So we have quite a way to go if we're going to meet the Paris Agreement targets. But some of the reasons, and I'm going to point this out because I think it is important for that uptick. The first is transportation, and that transportation footprint from some of the reading that I was doing just the other day, a lot of that actually has to do with flying, because and increased demands for jet fuel, because you're still pumping carbon. It's not just driving your car, it's using airplanes. The second is electricity generation. Now, we've seen record retirements of coal-fired power plants recently. However, that has been replaced by natural gas. And natural gas, you're still using methane. That is still a greenhouse gas that is in fact more potent than CO2. And we've hit the point where in that particular year, in 2018, we had record cold snaps and record heat. Record cold, you turn on the heat. Record heat, you turn on the air conditioning. And so that increasing demand pumped up the natural gas plants. And so we saw increases in our energy footprint. And then industrial emissions also increasing. And a lot of that, we believe, is related to building codes and building efficiency standards. And I won't go into that, I won't belabor that. So how are we doing here in Nevada? This is information from the last greenhouse gas inventory that was put together by NDEP in the Department of Conservation and Natural Resources. And what you see on the left, that's the actual inventory for the state historically. And on the right are projections of where we would be in the future given current policies that are in place. And there's only a couple things that I want you to take away from this. The first is that transportation is responsible for the largest quantity of carbon that the state of Nevada is pumping into the air. And that is primarily from tailpipe emissions. The second is the massive increase in industrial emissions. And this increase is, we can directly relate, again, this goes to those building codes and building efficiency standards, but specifically air conditioning. Air conditioning, you're pumping HFCs into the atmosphere, and HFCs, again, huge global warming potentials, but they're more potent than CO2. And then finally, I want to point out this land use component at the bottom where it's a negative. I talked about the planet breathing. Our natural landscapes and our natural ecosystems actually are natural storage of carbon. So we are really trying to get a hold on how much carbon is stored in the landscape, our desert landscapes, our forests across our state. So that way we can look at what are the opportunities to draw down carbon in our state through land use. Now, in the last legislative session and with Governor Sisolak's inauguration, there's been a flurry of activity related to climate. The first was Governor Sisolak committed Nevada to the U.S. Climate Alliance. And that essentially meant that we adopted the goals of the Paris Accords as a state. But then in the legislature, there were two key bills passed. The first was SB 358, which set new renewable portfolio standards for the state, meaning that we need to be at 100% renewable energy by 2050. And then this was followed on by adoption of what I would argue are among the most aggressive emissions reduction standards in the entire United States. And that is, we intend to be net zero by 2050. These are going to be very difficult. That is going to be a tough goal to hit, but I'm pretty confident actually that we can do that in our state. The bill, SB 254, which is championed by Senator Brooks, actually, this also requires this annual greenhouse gas inventory and a catalog of policy options to reduce our emissions, as well as projections of future emissions based on adopted policies, which is what I just showed you. This was followed on by Executive Order 2019-22, which was adopted in November of 2019. And this instructs the Department of Conservation and Natural Resources and the Governor's Office of Energy to lead the implementation of a climate strategy and climate action across the state. And it is essentially an interagency collaboration to address the challenges of climate change. It also contemplates that we need to deliver a climate strategy for the state by December 1st. And so in my role as the new state climate policy director or coordinator, that's what I'm doing, is I'm the one who gets to herd all the cats and try to put together a strategy. So I'm going to talk just very briefly about what we're trying to do with this strategy, because I think this is really important. The first is that we want to identify what policies we need to adopt to achieve our emissions reductions. And you can see there, I laid out what those specific reduction targets are. And this is going to be a little difficult, but it is a bit, but we can, I'm confident we can do it. Okay, I want to make sure that I speed this up a little bit. And the way that we're going to analyze our policies, and I think this is important because and you'll see why in a second. And we're going to analyze each policy that we're contemplating using 4 different metrics. Now, I'm going to use a hypothetical policy that I'm calling, we're going to dig a big hole and we're going to put a whole bunch of carbon in it, okay? Because I don't want to choose a real policy because we haven't gone through these analyses. So say I do the modeling on this hypothetical policy and it says, wow, we could completely ameliorate all of the carbon that we're pumping into the air here in Nevada. So I'm going to give this a green light. This gets a green because yes, we can accomplish what we need to. Climate justice. Now let me think about this. Unfortunately, the only places where we can dig these holes are adjacent to low-income communities. At the same time, we might have an opportunity for job creation for some of these communities. Well, let's think about it. You know what? We need to do more consultation with the stakeholders and with the folks in these communities before we adopt this kind of policy. So that might get a status orange. And then third, budgetary economic implications. Let's say, wow, this is actually, the state is going to have to pony up for the initial construction or digging of the hole, which is call it that. But then the longer term curation of the project is all going to be privately financed. So let's just say there's some big mega company that says, and we're going to pay for the long term if state you do this. Well, we got to think about that because we need to think about the long-term ROI, because let's say we don't have those data. So let's give that one a phase yellow. And then finally, political or policy feasibility. This sounds like a great idea, but let's say our hypothetical congressional delegation just says, well, actually, there's some federal rule that says you can't possibly do this and it's going to take an act of Congress. Well, that one might get a red because that's going to be very difficult. So the idea is that instead of saying, here's recommendation 1, 2, 3, and 4, we're really going to set the stage for where we need to move, where we need to focus on policies and get more information so that we are ensuring that we're moving forward with the best available information. And if we're not, because we do need to do a lot of different things to meet these targets, that we fully understand some of the risks. And I want to point out again, this climate justice component is very important and is a key part of how we're going to be assessing these different policies. I also just want to point to the stakeholder engagement component. Now, again, this is due December 1st, and obviously because of the pandemic, this has really held us back in terms of what we need to be doing. But we've had to rethink how we're approaching things. But we will be soliciting input through a survey. We will be holding topical office hours, and we hope to be announcing these in the next couple weeks. The idea being that we're going to have a couple experts from the state on different topics relevant to carbon emissions mitigation, invite members of the public and interested constituents to have a conversation and to hear what their concerns might be or any sort of ideas that they might have on different topics around climate and carbon mitigation. And then finally, we want to have open input through our website, which brings me to this. We are launching a State of Nevada Climate Initiative, and this climate initiative is meant to really encapsulate all of the climate action happening in the state and all of the policy options moving forward. It's really, we want it to be a place where there's an educational resource. We hope to, at some point, develop a decision support portal for our very sophisticated users in our community who really want to dig down into wonky information about temperature or hydrology. We want to incorporate a climate action dashboard that shows what actions are being taken by the state, just to demonstrate we are moving forward with climate action. We are addressing this critical issue. It will be the home to the climate strategy. And what I just laid out before about stakeholder engagement, you can look to this website, and I put the URL here for how to engage in the process. And then finally, it's going to be really where we want to have, it's the home for engagement and action more broadly, again, on climate. Climate is a discussion, and we want to make sure that we get as much input from folks as possible. And this is just one example. I'm running out of time, so I want to make sure, but I do want to make sure that I point to it. You know, when it comes to what's happened and what we're experiencing right now and our economy, we've really burned down the proverbial house. And I just have, if you burn the house down, you're not going to rebuild the 1985 pink house with glass brick that you had. You're going to rebuild not just for today, but for the future. And so that's the way I think we need to be thinking about economic recovery. And climate friendly approaches to rebuilding the economy can have a very important part in the rebuilding and recovery here in Nevada. We have more solar potential in our state than any other state in the United States. We have the opportunity to build out utility scale as well as modular solar, which is a job creator. We have, one of the largest electric vehicle plants in the entire United States. There is tremendous opportunity for our state to really lead on clean and green jobs. I don't love the phrase clean and green, but that's the way I'll characterize it. But this is so much bigger than that too. We have amazing outdoor opportunities. So building out an outdoor recreation and changing that perception of our part of Nevada as just being the Strip. I mean, it's incredibly important and it's wonderful, but we have so many other wonderful things to espouse about what we do here in Southern Nevada that we can leverage to rebuild our economy. So I very briefly want to talk about what UNLV can do. So I am a huge fan. What really motivates me personally is seeing climate in action. Science in action. I like to see science that's going to solve problems, and that is it's going to speak to what are the big issues that we're facing in our communities. And across the United States, there's a University Climate Change Coalition. It is made up of major R1 institutions that are prototyping a collaborative model where they're working with their communities to address the issues related to climate change with their faculty. And I would love to see UNLV as a brand new R1 institution join this consortia. We have huge issues in our community with climate. I hope that came across in this presentation, and I really think this is a huge opportunity for us. Similarly, UNLV has the opportunity to lead by example. Now, this is kind of a wonky academic thing, but universities across the United States adopt something called STARS, and it is the standard for are you a sustainable campus? And Nevada is one of the few states where there is no university or there's no institution that has a current STARS rating. However, there is UNLV at one point did. Ours is expired now, but we're the only institution that ever even historically did. And I'm proud to say, and I think it's really exciting, that UNLV, College of Southern Nevada, and NSC are collaborating right now. And we've had some very interesting discussions on how we can create a sustainability and resilience consortia among the institutions to really try and get at this and make our campuses more sustainable and climate friendly. And then finally, what can you do? We're in I can say drive an electric vehicle, reduce your carbon footprint, but right now we're in a situation where everybody on this planet has a perspective on what's happening. We're all experiencing just these profound, visceral things in general, and they're just cutting to the quick in terms of everything. It's just, I don't even need to say it. We're all experiencing it. But we're all learning how to advocate for ourselves. We're learning how to advocate for our communities and things that we care about and our values. And we're learning how to have those difficult conversations, particularly when we're advocating for our future. So my hope is that when we emerge from all of this, that we're going to have a society where we're able to have these difficult conversations and recognize that by having them, we're going to be in a better place in the end. And climate change is one of those places where this needs to happen. I'm hoping that we can have those difficult conversations. I'm hoping people realize that they need to trust the experts, trust the scientists. My gosh, Dr. Fauci is my freaking hero right now. The guy knows what he's doing. And that we trust our communities. We trust the people that are being impacted, and we trust we trust that what they're experiencing is important and that it needs to be addressed. So I just urge you, please be part of the discussion. Talk about climate, talk about some of the things that you heard today and why it is relevant. This is not tangential to what's happening to us today. It is directly related. And with that, I just want to say, please wash your hands and wear a mask. So thank you.
Thank you so much. That really gave us an insight. And right now I do not see any questions coming in through the Q&A, but I have a question is, what's a small thing that we can do in our lives to make a change?
You know, I think one of the things that we're all learning through this pandemic is that we can work from home. And when I talked about the carbon emissions or the reductions that we've seen in carbon lately, about half of those emissions reductions are just because of declines in transportation. I think that by being able to have the ability to work from home periodically will be incredibly profound, not just from the carbon standpoint, but from the air quality standpoint. Ground level ozone pollution is from tailpipe emissions. So the less cars we have on the road that are pumping out funky stuff, the better.
I agree.
No questions?
Yes, there's one question that came in, but let me just double check, make sure I'm not missing someone else's question. What large scale and practical change can Nevada do to mitigate this increase in temperature?
So I think that there are going to be some really interesting options that are going to be considered when we develop this climate strategy, because they are going to be larger scale policy options. And one of the exercises that we need to go through is to really figure out what policies are going to give us the biggest bang for our proverbial buck when it comes to reducing carbon. And I don't think we have a good idea on what that is yet. And that's part of the process that we really want to be launching. That said, I think everybody needs to do at least a little bit of something, just like I talked about. I mean, I'd be a hypocrite if I didn't say, you know, I drive my car. I'm not perfect. I used to fly on planes anyway. And, you know, it's difficult. But I think, again, having these discussions in our community and understanding the connection between reducing carbon and why that impacts the low income community that is in your neighborhood, that has to happen. We have to understand that there are direct impacts that impact every single person in this state.
We have another question from Lance. Can you talk more about the importance of policy and mandates to achieve carbon reduction goals?
Can you say that one more time?
Can you talk more about the importance of policy and mandates to achieving carbon reduction goals?
I think that's a great question. I think that they're critical, quite frankly. I think we've demonstrated, even through the pandemic, as an example, you know, we were told to stay home and don't drive our cars. So we did that, and look at the emissions reductions that we were able to achieve. And that's what it took. I'm not saying that it should be that heavy-handed when we're talking about climate and climate reductions, because again, this is a discussion, but we have to realize there's no perfect silver bullet for how we move forward. Any sort of policies, different things that are going to be adopted, there's going to be pros and cons. And we need to make sure that we truly understand that entire constellation of information when we move forward with some of these things. That said, it's going to take big, bold action, because again, I talked about that emissions reduction that we achieved from the COVID, but you saw it put barely a dent in the actual concentrations, and the concentrations in the atmosphere are what drive those temperature increases.
We have a question from Andrea. Are you hopeful these efforts will survive the statewide budget cuts?
I'm optimistic because I think that, and here's the way that I'll put it, we are all going to be challenged by the budget cuts that are coming along. But I am confident that this touches on so many different things that even those things that we do invest in, the very few things that we're able to, climate will have a touch point. Climate impacts not just everyone, but every single thing we do. There's a reason that the executive order considers it's an interagency, because every agency is impacted across the state. Every agency deals with something related to climate change.
Next question is from Alexa. In order to hit the targets the state set for 2030 and 2050, will there be a requirement for local entities to build net zero buildings in their public works departments?
That's a really interesting idea. I will say we have a starting list of policies that we're going to be assessing, and those actually come from that greenhouse gas inventory from last time. But that kind of idea or that kind of suggestion is the kind of thing that we want to make sure, and I'm going to write it down. That's the kind of thing that we make sure that we collect through our stakeholder process. And again, it's going to be more difficult with COVID. But we're going to do it. And actually, that gives me the opportunity to say one other thing. What happens in December with this strategy, this is meant to lay the long-term groundwork for climate across the state. It's intended to stitch climate into the thinking and decision-making across our entire state. It is not, here's the strategy, that's it, one and done. It's meant to be step 1A among 1,000-part process. Climate is with us, and it's something that we just need to continue to deal with. So the strategy is not the end all and be all. And I will also just say that TRL, I'm calling it technology readiness concept around the red, green, the colored boxes is meant to basically show progress and where we need to focus our different efforts to assess these different policies in terms of whether or not they're ready, their readiness level for adoption.
Thank you. I do not see any other questions coming in at the moment. Does anyone else have questions? No. I think we are good on the questions. I just want to thank you again for spending time with us and sharing your insight and expertise. This definitely changes my thinking just at home and driving vehicles. So thank you so much for that insight, and I'm excited to be a part of the change.
Thank you.
I'm going to stop recording.